Hello, if you have clicked this thumbnail, then you should be wondering how to solve this unique Olympiad maths question. You're in the right place. Pause a little and ask yourself, how do I solve for a in the a root of negative a equal to 27? In this video, we are going to work together on two solutions, two methods of solutions. And as we work these two methods of solution, we are going to see how we use principles of mathematics in solving this question. First, we're going to start with the simplest method. And the simplest method, we're going to use some rules of indices. From this expression, you know that a root of negative a can be expressed in fractional form, right? Good. And then that is exactly what we are going to do. If you recall the law of indices, if I have the square root of the nth root of a, that can give me a to the power of 1 divided by n, right? So if I apply that expression, I'm going to solve or simplify this expression. So this is going to give me negative a to the power of 1 divided by a, right? And this will be equal to 27. Remember, we are taking method 1, the easiest method. Now, if we consider this easiest method, you ask yourself, how do I simplify this? Now, considering this easiest method, I want us to take the value of negative, or take the value of 1 divided by a. Assume the value of 1 divided by a to be equal to negative y. So if I have the value of 1 divided by a to be equal to negative y, right? Good. That simply tells me that negative a can be equal to 1 divided by y. This assumption can be true. And from this assumption, I can also look at my a to be equal to negative 1 divided by y, right? So any of these can actually be right for that expression. So if I have that expression can now give me, if I have that expression, my negative a can now give me 1 divided by y, right? So I'll have this expression to give me 1 divided by y all to the power of 1 divided by a will now give me a negative what? Y, and this is equal to 7. So I can simplify that. If I simplify that, 1 divided by y to the power of negative y can be sorted out using the laws of indices. You recall the law of indices. If I have 1 divided by y, this can simply give me y to the power of negative 1, right? So if I multiply it with y, that whole expression with negative y, that whole expression will give me y to the power of y. So this expression is going to give me y to the power of y, and that will give me what? 2 to the power 27 can give me 3 to the power of what? Of 3, right? We will now have same base, same power. So with same base, same power, our y can simply be equal to 3. And that is the solution to this expression. That is not the solution. Remember, we are looking for the value of a. And we said a can be equal to negative 1 divided by y, right? So if a can be equal to negative 1 divided by y, so the value of a will be equal to negative 1 divided by 3, and this becomes the value of a that satisfies that expression given to us up there. Great. Now this is the solution to method 1, which is the shortest method you can ever think of in solving this question. Now let's look at another method. This method can be a little bit longer, but then stay tuned and then see how we'll find a solution to this question. Method 2. Remember, we are asked to find the h root of the a root of negative a, which is the value of a in the h root of negative a, which is equal to 27. Now, what method can we use in finding the solution to this question? Now, let's consider one unique method. We're still going to apply some rules of indices. If I simplify this the way I did the other expression, I'm going to have this to become negative a, right, all to the power of 1 divided by a, and this will be equal to 27. Great. Now at this point, what do? I have to take power a of both sides, and that will help me clear the fractional power I have here. So if I multiply both sides by a, I'm going to have that expression to now give me negative a to the power of 1 divided by a multiplied by a, and this will be equal to 27 to the power of a. Great. Now from this expression, you see that a will simply cancel out a, and then I'll have my result there to be negative a equal to 27 to the power of a. Great. Now what do we do from here? To get a solution to this expression, I'll simply want to divide both sides by 27a. Now, why am I dividing both sides by 27a? So as to make the right hand side equal to 1. So if I divide here by 27 to the power of a and divide here by 27 to the power of a, just check out what this will result to. This will cancel out this to give us 1, and then we'll have our negative a divided by 27 to the power of a will be equal to 1. Great. Now from that expression, we can simplify further. But I want you to ask yourself, what do I do from here that can further simplify this expression to a more simpler expression? Now, at this point, we want to look at how we can mend this solution or this expression in order to get a simpler expression such that we can easily apply the Lambert principle. From this expression now, we can see that this expression can give us negative a multiplying 27 to the power of negative a, right? And this will be equal to 1. We haven't changed anything because 27 to the power of negative a is still 1 divided by 27 to the power of a. Now, if you look at that expression very well, I want to consider using one simple logic. From that simple logic, you can come to find out that in that simple expression, if we have the exponent of n of x, right? This is very straightforward. This will be equal to x. Now, what if I have the exponent of n of 27? What will it give me? This will simply give me what? 27. That means I can simply replace 27 with the exponent of n of 27. Now let me try that. If I try that in that expression will now give me negative a, right? That expression will now give me negative a multiplied by the exponent of the n of 27, and all of these will multiply negative a, and that will be equal to 1. Great. Now if I look at that expression very well, I can simplify that expression by multiplying the index. If I multiply the index, I'll have this to become negative a multiplying the exponent of negative a multiplying the n of negative a multiplying the in of, that's what this is going to give me, negative a multiplying the in of 27, and this will be equal to 1. Good. Now in that expression you can see something happening. I want to mend this expression such that I'll have an expression in which I can use the Lambert W function. Now what do I do? In order to get a Lambert W function, I need to multiply both sides by the in of 27. If I multiply both sides by the in of 27, I can get similar to something that is the power of this, right? So let me multiply both sides by the in of 27. That will give me the in of 27 multiplying all of these, negative a multiplying the exponent of negative a in of 27, right? And this will be equal to the in of what? The in of 27. 1 multiplying the in of 27. Because what I've done to the left hand side, I'll definitely do to the right hand side. So that whole expression will now give me a negative a multiplying the in of 27, right? And this will be multiplying the exponent value of negative a in of 27, and this will be equal to the in of what? 27. Great. Now if you look at that expression very well, you see that this expression has now looked like what? Like this. And what I need to do is to simplify further. Now if I simplify further, I'm going to reduce this other expression to give me negative a in of 27 multiplying the exponent of negative a in of 27, and this will be equal to in of 3 to the power of 3. And according to the law of indices and logarithm, this will come over here, and I'll have that expression to now give me negative a in of 27 multiplying the exponent of negative a in of 27, and this will be equal to 3 multiplying the in of 3. So from this point, I can easily expand the right hand side too. Recall that we said earlier on that if I have the in of the exponent of in of x, this can be equal to x, right? So that means if I have the exponent of in of 3, this can still be equal to 3. So that means I can replace that with this. If I do that, I'm going to have that whole expression to now give me negative a in of 27 multiplying the exponent of negative a in of 27, and this will be equal to the exponent of in of 3 multiplying the in of what? Of 3. Good. So at this point, I can now apply the Lambert W function. And what does the Lambert W function say? If I have a function of x multiplying the exponent of e of x, right? This can simply give me what? The value x, right? That is exactly what Lambert W function states. So from this expression, if I check out the left and the right hand side, having gotten this and this, having gotten this and this, remember this can simply multiply this, because if I rearrange that expression, I can have negative a in of 27 multiplying this expression negative a in of 27, and that can give me in of 3 multiplying the exponent value of in of 3. Now if I compile those two expressions to the Lambert W function, I'll have those two expressions to only give me negative a in of 27 to be equal to the in of what? Of 3. That's all. So from that expression, I can simply simplify further. Now if I simplify further, I'm going to have that expression to now give me my negative a in of 3 to the power of 3, right? And this will be equal to in of 3. If I simplify this, I'll have negative 3a, right? According to the law of logarithm, this will come over here, and that will give me in of 3 equal to in of 3. Now if I simplify this, I'm going to divide both sides by the in of 3, and I'll divide here by the in of 3. Now the in of 3 will simply cancel out the in of 3, and this will simply give me 1, and so I'll have my negative 3a to be equal to 1. If I divide both sides by negative 3, divide here by negative 3, I have my solution, the value of a to be equal to negative 1 divided by 3, which is the solution to that mass expression given to me out there. So this is the solution using method 2, and you see we got exactly the same solution with that of method 1. So what does that tell us? That tells us that a equal to 1 divided by 3 is the solution to that mass expression given to us up there. Now I want to give you a task. The task is insert the value of negative 1 divided by 3 into that original expression and see if the left hand side will be equal to the right hand side. If you do that and you find it to be same, do comment your answer in the comment section, and I will be so glad to engage with you. Thanks so much for watching, and remember to subscribe to my channel for more simplified maths content. We appreciate your super thanks. That will help our channel go a long way. Thanks so much, and see you next time.